In this video, we'll explore solving radical equations. Now, some general suggestions to help out. First, you want to try to isolate the radical of the variables inside, especially if there's just one radical. If you have multiple radicals, you're probably going to have to repeat the process, and it may help to put one on each side and then try to go through the simplification. And sometimes you might be able to use what's called the substitution method, which we'll look at in a little bit. So say I have this problem, the quantity x minus 4 is in the square root, minus 7 equals 2. So first thing I want to do is isolate that radical since there's only one in the problem. So in that case, I'm going to add 7 to both sides. Now I have the square root of the quantity x minus 4 equals 9. And I know this is going to be possible because a square root can equal a positive number. So now I'm going to square both sides. That gives me x minus 4 equals 81, and now I just solve the problem. I add 4 to both sides, x is 85. Now I want to check my work because it's always good to check, and when I do that, I'm going to plug in 85. That's going to give me the square root of 81. When I simplify that, that's 9 minus 7, which gives me 2 equals 2. So x equals 85 is my solution. Now say in this case I have two radicals and there's not really any relationship between the two. So what I'm going to do is I'm going to move the second radical to the other side. Now I need to remove my radicals as much as possible, so I'm going to square both sides. When I do that, the left side just becomes 5x plus 10. And the second side, I treat this like it's a variable, and I'd be actually using my double distribution here. So I've got the first quantity squared plus the second quantity squared, and then I've got to remember that I've got those two terms. They're going to be added together in the middle. So I simplify. So this whole quantity, the radical of this whole quantity becomes x minus 2. And then I've got minus 2 plus 16. So I've got x plus 14. And I still have a radical here though. So what I want to do is I want to get everything away, and I want to get the radical by itself again. So I'm going to move the x and the 14. That's going to give me 4x minus 4. And then we'll divide everything by 8. And that gives me x over 2 minus 1/2 equals the square root of x minus 2. Again, now I need to square both sides. When I do that, I get some crazy fractions here that are not necessarily easy to work with. So I'd say, well, instead of dealing with the fractions, let's just multiply everything by 4 so that my fractions go away. And you can do that as long as you do it to both sides. So when I do that, I end up with x squared minus 2x plus 1, and then 4x minus 8. Again, I multiplied every single term in my equation by 4. Not just the one side, but both sides. So now, if I look, I've got an x squared term. So the easiest thing to do, I'm going to create a quadratic equation and see if I can factor it. So I move my 4x and my minus 8. I'm going to subtract the 4x, add the 8 to both sides, and that's going to give me negative 6x plus 9. And I say, well, can I factor that? And yes, it is factorable. And you can go through the steps and you get to x minus 3 times x minus 3. So that means I'm only going to have one possible solution. So x minus 3 equals 0, and that'd have to be x equals 0, or x equals 3. And you can go back and plug in 3, and you get 15 plus 10, so I got square root of 25, minus the square root of 1, that's 5 minus 1 is 4, 4 equals 4. Now the substitution method says that sometimes you may want to actually use substitution to create a factorable quadratic equation. And what you're looking at typically is the nth root of x, and you're going to replace that with u. And sometimes that'll create a u squared opportunity. So let's look at an example of how this could potentially be used. So say I have x minus the square root of x minus 6 equals 0. So there is this relationship between the x and the square root of x, but I can't do much with it now. So if I instead say that u is the square root of x, then what I would say is that u squared is x. Because if I think about how, if I square this, square root of x is x. So I'll replace both the square root of x with u and the standard x I have in this equation with u squared. So I've got u squared minus u minus 6. Now look how much easier that is to solve, because that becomes x minus 3 and x plus 2, or u minus 3 and u plus 2. I can set each of those equal to 0. Now I can go back and replace in my square root of x so that I would figure out exactly what are the potential values. So instead of using u, I now plug in the square root of x. So the square root of 3, well, our square root of x equals 3. I'd square both sides. That gives me 9. Here I've got the square root of x equals negative 2. Well, I can't have a negative square root for a real solution. So in this case, there is no real solution right here. So the only possible solution would be x equals 9. And I can plug that in. 9 minus 3 minus 6 equals 0.